Hello and welcome to this online lecture about calculating what is called heat of reaction. It's also sometimes referred to as enthalpy, which is kind of a weird word, enthalpy of reaction, and it's often notated with a delta, which is a Greek letter that looks like a triangle, H. So oftentimes when I say heat of reaction or enthalpy of reaction, I might just write delta H. And the way that for this class that you probably should be thinking about heat of reaction is it's the change in heat energy that occurs, the overall change that occurs when a chemical reaction happens. So is energy going in to the matter as the chemical reaction happens, or is energy coming out of the matter as the chemical reaction happens? And how much? So I'm going to show you how to calculate this. It's not really that difficult, but because this is kind of all unfamiliar territory, it might take a listen or two to this lecture and a little bit of practice before you get it. But it's really not that difficult. In order to calculate heat of reaction, you need to know something called the heat of formation for all the products and all the reactants. So heat of formation is usually H with a little f. It's heat of formation. And it's the energy change. Let me write this first. It's the energy change that happens when lone atoms or ions bond together to actually form the compound in question. So that's basically what heat of formation is. And what you do basically for your reaction is you'll add up all of the heat of formations for your products. So you take the sum of the heat of formation for all of your products, and sum means you add them all up, and from that number you subtract the sum of the heat of formation of all of the reactants. Now just a few quick places where students will make mistakes. I want you to I'm going to be very obvious here. I want to point out to you that it's the sum of the heat of formation of the products, which is usually the second thing you see in the chemical equation, minus the sum of the heat of formation of the reactants, which is usually the first thing that you see in the chemical equation. So don't let that throw you for a loop. You're taking the compounds, the heat of formation of all the compounds at the end of the reaction, and you're subtracting the heat of formation of all of the compounds that are there when the reaction starts. And that's basically all there is to it. If you're interested in like why this works or how this works, I can point out some more advanced videos for you that can help answer some of those questions. But for the scope of this class, all I'm going to do in this video now is show you some examples of mathematically how you do that. And at the end of this video, you should be you should feel really comfortable in figuring out if in calculating the heat of formation for any reaction that I give you. So here we go. Well, I'm going to go ahead and just pick a reaction. We'll do let's see. Let's do carbon dioxide reacting with water to form carbonic acid, which is H2CO3. Okay, so we've got, let's use different colors here. We've got to identify the products and the reactants and then get the heat of formation for each one. So the products, there's only one product and there are two reactants. So what I'm going to do is I'm going to find the heat of reaction for each one of these compounds. I'm going to add that together, and then from that I'm going to subtract. See, I just messed it up there myself. I'm going to take the heat of reaction of the single compound, and from that I'm going to subtract the heat of reaction for each one of these reactants. So I'm going to use the handy dandy internet and look these heat of formations up. The heat of formations will be given to you for these problems. You won't have to find them anywhere. They'll be right there for you. You won't have to go hunting for them. So the HF of carbonic acid equals, let me see, I just had it up here, negative 275.2. Now these are almost always going to be measured in something called a kilojoule per mole. So, you know, the prefix kilo means 1,000, and joule is the SI unit for measuring energy. So, and you'll notice it's negative. That means that the energy is coming out instead of going in. So that's the carbonic acid. Now, heat of formation for carbon dioxide is, let's see, it's negative 393.5. And then the heat of formation for water, and that one is 241.8. Negative 241.8. Okay. So now that I have my amounts, I can go ahead and calculate the heat of formation by taking the product, and the product is the carbonic acid, and subtracting the sum of the two reactants, which are here, those two. So basically it's going to be negative 275.2 minus negative 393.5 plus negative 241.8. So let me grab my calculator really fast here. Okay, so first thing I'm going to do is add these two together. So 393.5 plus 241.8. So those two totaled is negative, oops, of course, I always forget that it does that. So it's 635.3. So negative 635.3. So now I have to take negative 275.2 and I have to subtract negative 635.3. Let me just scooch this up a little bit. Bring my calculator back, clear that out. And negative 275.2 minus negative 630. Hold on, I messed that up, I think. Let's try that again. 635.3. So, that doesn't look right. I must have miskeyed something there. So I'm just gonna do that again. So it's 275.2, and we have to make that negative, and we're going to subtract 635.3, and we're going to make that negative. And there we go. That's a lot better. So I get a positive, and of course it hides on me again. Positive 360.1. 360.1 kilojoules per mole. Now it's positive, so what does that mean? Well, if it's negative, that means energy is going to come out when the reaction runs, and if it's positive, it means energy is going to go in when the reaction runs. So we are going to learn in the next lecture that since the energy is going in, this would be considered an endothermic reaction because the delta H is positive here. But that's how it's calculated. You subtract the total of the reactants from the total of the products, and you will get the heat of reaction. Make sure you do not get confused by all of the signs. Make sure you keep your signs straight. You saw I almost had a problem with that with the calculator. So that's it. That's how you do these calculations. They're not that difficult at all. It's all addition and subtraction. If you have any questions, as always, feel free to ask them in class, and thank you for watching.